Hello again. This is Dr. James Camp from Lee College in Baytown, Texas, and this is my 10th and final lesson in the Starting Off in C++ series that I've been recording. Today we're going to talk about probably the most difficult to grasp but most useful property of object-oriented programming, something called polymorphism. Okay, why would we want to do inheritance and why would we want to do polymorphism? Oftentimes, we want to work with a list of objects that are related in some way. Okay, what we call an is a relationship. Um, a car is a vehicle, so car might inherit from vehicle. Um, a uh, button is a uh, graphical interface object, so it might inherit from interface object. Um, there are, a salaried employee is a employee, a hourly wage employee is a employee, so they might both inherit from employee. As you can see in these cases, these all share some characteristic or behavior. Employees all get paid, whether it's hourly or on a salary. Um, cars and cars might inherit from vehicle, trucks might inherit from vehicle, motorcycles might inherit from vehicle. They all have wheels. They all drive on the road. Um, so they all have some characteristic or behavior, but they're distinctly different in other ways. Trucks have more cargo capacity. Motorcycles only have two wheels. Um, so um, the nice thing about inheritance and polymorphism is that sometimes you don't need to know those distinctly different details in order to work with the objects. If we were simulating vehicles in traffic, we wouldn't need to know that a motorcycle only had two wheels. We'd just have to call its motorcycle.drive um, method, and then we could also call car.drive and truck.drive, and they would all try to go forward in traffic, and we could simulate how that works. And that idea that you can work with multiple different kinds of objects in the same way because they all derive from the same parent class is called polymorphism. Okay. In these cases, we can let the related objects inherit their common traits or behaviors from a parent class. Okay, so like I said, the simulated motorcycle and car and truck all inherit a drive function from their common parent vehicle. We can build a list of parent class objects that nonetheless have the distinctive properties and behaviors of the child classes. Okay, the fact that we could make a list of vehicle, okay, call it an array or a vector of vehicle, and we can populate that with a car here, a motorcycle there, a truck there, another car. They all are vehicles, so they all work in our list of vehicles. And we can call vehicle.drive, and it doesn't matter whether we have a car or a motorcycle or a truck, they'll all have a drive method that will take them along the road. Okay, that is polymorphism. Okay, some examples of polymorphic objects in real life that you could maybe relate to a little better. A paycheck object and an invoice object might both derive from a class called payable, a parent class called payable. And they would share a get payment method that tells the company that's tracking its paychecks and its invoices how much it needs to pay each of those things. So we could have a list of employees with paychecks, contractors with paychecks, um, invoices from our suppliers, and we don't have to have three different lists. We can have one list of all of those things that um, for all of them we just click through and say payable dot get payment, and um, it knows how to look that up because it knows what the object knows whether it's a paycheck or an invoice. Um, a cylinder, a sphere, and a box might all derive from class 3D shape, okay? And they would share a get surface area and a get volume method, which would be, of course, implemented differently on a cylinder, a sphere, and a box. They would be completely different formulas for each of those. Class predator and class prey and class plant, if we're simulating an ecosystem, might all derive from class living thing, okay? And they would have some different behaviors, but they would all have a reproduce function that expands their population and a feed function that attempts to get sustenance, okay? I guess plants would have to feed on CO2 and sunlight, right? But plants would feed themselves. Prey would eat the plants, and predators would eat the prey. Okay. Different kinds of graphical interface buttons might all derive from class button. Okay. So you might have buttons that do something directly. You might have buttons that pop up a menu. You might have checkbox buttons or buttons that add plus or minus to a value, or you have all sorts of different kinds of buttons in your interface, but they all have a do this when clicked behavior method that they derive from class button. Okay, today's project, we're going to be looking at storage tanks. Say a local chemical company has hired you to build a program for them. They store their products in either spherical or cylindrical tanks. If you've driven enough around Southeast Texas, you've seen these, what my wife calls tank farms, of big cylinders and spheres that are containing chemicals. The company wants you to build a program to track both kinds of tanks, but they want one list, okay? They just want one inventory list of all the tanks that they have in their facility. And they want your program to report how much volume each tank will store. So we can define a storage tank class with member functions get type that will return either cylinder or sphere, and get volume that will calculate the appropriate volume depending on whether it's a sphere or a cylinder. And then we let sphere tank and cylinder tank both inherit from storage tank so that we can have one list of storage tank, but polymorphically, some of them are spheres and some of them are cylinders. Okay, so this is how inheritance syntax works in C++. If you've used other languages to program object-oriented programming before, this may be different. Java uses an actual keyword there to indicate that one class extends another class or something like that. Here we use a colon as our inheritance marker. So child class, that colon is read, inherits from parent class. Okay. Generally, it doesn't, inheriting private properties of the parent class doesn't make much sense because they're private to the parent class, and now you're going to have your own private variables in the child class. So, whatever you need there. But public, you're going to have um, member functions. You're going to have your own, the child class is going to have its own constructor here, but then it's going to have an inherited member function, at least one member function that it inherits from the parent class, like drive in the case of our vehicle class that we've been talking about. Now there's an important keyword here. If you're trying to do polymorphism, you need to have these inherited member functions be virtual. That means that the exactly which member function is going to be called is determined at runtime, not compile time. So you can call member function on the parent, on a parent class pointer, and it will run the child class version that's correct for whichever child that pointer is pointing to. And if that's a little confusing, hopefully it will make sense as we work our way through the code. Now we've got our usual contingent of pound includes, IOStream, IOManip. CMath is going to help us with calculating the volumes of the tanks. Vector is going to help us keep track of all the tanks. And we've got use math defined so that we can get the pi constant. Okay, now we're going to define the base or parent class. Now this parent actually doesn't need any data members because it's not keeping track of a particular size, because a storage tank that has no shape cannot have a size. It just needs to set up dummy functions for the child classes to inherit. And of course, we're going to make those virtual. We're going to make those virtual functions so that these can be polymorphic in C++. Okay, now we're going to define the derived classes. Okay, these have real data and do real calculations. Notice here that we've got sphere tank colon storage tank. So that indicates that sphere tank is inheriting from storage tank. What's it inheriting? It's inheriting the virtual string get shape and the virtual double get volume. We also have a cylinder tank, which has this time a radius and a height. And we've got a get shape and a get volume here as well. And then cylinder tank has a more complicated constructor than the other one, so we've got it defined as a separate function sitting here. Now, we've defined our functions, we've defined our objects, they've each got the appropriate geometric function for calculating volume, and they've each got a return one word function for type. This, here in our body of our program, is where the magic of polymorphism happens. Okay, we have a vector of storage tank pointers, and the idea here is that these pointers can point to any class that's derived from storage tank. They don't have to just point to storage tank, they can point to anything that inherits from storage tank. And that's going to be true for the this tank pointer as well. Now we can set up an input loop that lets us create either spheres or cylinders. Okay, so the user types sph for sphere or sil for cylinder or they type end because they're done with the list. If type is sv, then we ask them to enter a tank diameter. They give us the diameter, and then again, here's the cool thing. We create a new sphere tank and call its constructor with the diameter, and then any pointer to a child class of storage tank can be cast to a storage tank pointer, and it will still work as a sphere tank. That's the polymorphism magic. Okay, so we can add it to tanks, called tanks.pushback this tank, and as far as tanks knows, we've just added another storage tank pointer, but that pointer is pointing to a sphere tank object. And you're going to see when we run this at the very end that it's going to remember that it was a sphere. Okay. Else, if the user types sil, we get a tank diameter and a tank height, and we call the cylinder tank constructor with the diameter and the height, and then we cast it to a storage tank pointer and push back into our tanks vector. Okay, so now we've constructed our whole list of tanks. Maybe we've got 3 or 4 of them, maybe we've got 10 or 20 of them, it doesn't matter. We can now loop through all of our tanks and print the shape and the volume from each tank without the main program needing to know which kind of tank each member of the list is. Okay, each tank, because it's an object, each tank knows what kind of tank it is, and the magic of polymorphism is that we can just call tank pointer get shape, tank pointer get volume, and it will just work. Because these are virtual methods, they can be called on parent class pointers, and they will still do the child class behaviors. Okay, here's some sample output. You can see that I typed in a sphere and gave it a diameter 20. Then I did a cylinder. Then I did another sphere. Then I did another cylinder. There's no reason why I had to alternate. I could have done 2 spheres and 2 cylinders. I could have done 3 cylinders and 1 sphere. And when I'm done here, it prints out. The first one prints that it's a sphere and calculates its correct volume. The next one prints that it's a cylinder and calculates its correct volume, and so on and so forth. So the polymorphism worked. Each object knows whether it's a sphere or a cylinder and knows how to calculate its volume. Okay, so in summary, what we've learned today is how one class, which we call the child class or the derived class or the subclass, can inherit from another class, which we call the parent class or the base class or the superclass. We learned how the is-a relationship defines inheritance. A sphere tank is a storage tank. A cylinder tank is a storage tank. Okay. We learned how child class objects can be pointed to by parent class pointers. Okay, enabling you to have a list of different kinds of objects that's still one a vector or an array of one type. It's an array of the parent type, but it points to lots of different child types. And we learned how the child class objects will still act like the child classes because of the magic of pointers and virtual functions. So we learned that you can have one list of objects of different types that all behave like the type they're supposed to behave like, and that is what we call polymorphism. Okay, now I'll have a polymorphism homework for you to work on the Blackboard site. Look forward to seeing you complete this unit and wrap up our class on C++. Until then, good luck and happy programming.